right, good morning, everyone. And I think we will all agree that AI is changing the way that we build and run software. And I guess with AI, we just have one more wave on top of a world that has been getting more and more complex. And I think we've heard from the previous speaker as well, how we've gone from on-premises servers to the cloud, from machines that run for a long time to ephemeral compute, from on-premises to cloud, and also the frequency of releases has been going faster and faster, right? Maybe in the past decade, at some point, we had quarterly releases, while now it's daily, it's multiple times a day. And AI is just adding more complexity in a world that is already complex, right? And if you think about what you can do with AI, you can build more code at a faster pace than ever before. You're able to, there is new protocols and new things that you have to support every day. And lastly, there is non-determinism that we're now embedding in every part of the application. So really, this talk is about how you can build, observe, and troubleshoot. And rather than how you can do that, is what is the impact that AI is having on this bit, and what can you do to adapt to this change? And yeah, as we said, my name is Michele Ricciardi, and I'm a sales engineer at Datadog. So let's get straight into it. So we'll look at how AI is changing the way that we build. In a recent 2025 Stack Overflow survey, I think 84% of developers said that they're using AI in their development process. And I think you'll agree with me that with AI, there are benefits, right? There is more code, and the promise is that you can get quicker to market. You can go from idea to execution much faster. And this is supported also by a recent DORA survey on the impact of generative AI to the software development lifecycle. So they said that at an individual level, so individual developers could see, for example, increased documentation quality. This is because developers typically, I've been a developer, and documentation is usually what you leave last, right? You don't spend the time writing documentation first, even though it's best practice. We all leave it last minute. And with AI, you generally can get better documentation because you can get something else to do it for you. And you can check it, of course. Better code quality, I think this is a bit controversial for me, but according to the DORA survey, if you're using AI assistant, you can get this AI assistant to maybe tell you about optimization techniques you weren't aware of, and ultimately you could end up with better code if you're iterating on your own and actually using it the right way, let's say. Faster review and approvals, this is more about, rather than relying on your own knowledge and relying on just the comments and your understanding of code, you can use AI tooling to help you understand that, and it makes it a bit quicker. So let's say if you've got a very large code base or a very large change, AI can help you read through that. So for example, some coding assistant enable you to review pull requests, let's say, and give you kind of an overview of what the pull request is about before you even go and look at the code. And lastly, reduce code complexity. Again, this is, for me, is a bit controversial, but the point here is that imagine you've got a very large legacy code base. In the past, you would have either hired someone to go through it and try and optimize it over time, but now with AI, you can, that process a bit faster, right? Imagine you've got very large code bases. Perhaps you can use AI to get a better feel of what's in there and how you can improve it, maybe how you can modularize. And while this is, of course, the promise of AI, there are also drawbacks. I mean, if you use this tooling blindly, they will introduce bugs into your production environment, and potentially the code quality will not be good, right? I mean, we all seen how these tools give you just a lot of output, and it's usually that means that that code is not necessarily succinct, and it's up to you to iterate and improve that. And lastly, if you are making changes, much more frequently with this AI tooling, now your CI/CD also has to keep up with it. If you've got 20 developers and they're all committing 20 features in a day, how is your CI/CD testing, gonna cope with that? What I found more interesting in that DORA report is that while there were improvements at an individual level, at an organizational level, they actually saw that the delivery throughput and the delivery stability has gone down. So this was in the latest report. And for me, surveys are important, but they don't really tell us the whole story. I think this is potentially true, but my question is, how do you measure the impact in your own organization? And I think there are two kind of parts to answer that question. One is data from the coding assistant, right? So this coding assistant generally can give you some dashboards, and you can get things like the number of suggestions that were accepted, the acceptance rate, so out of all of the suggestions that are provided, how many of them are accepted, the number of lines per suggestions, and the numbers of engaged users. So if you've got this type of data, you're then able to identify, for example, who are the teams that are using this assistant the most, let's say in your organization, how many lines of code they're accepting, and so on. So this tells you one part of the story, which is the tool being useful, and are we leveraging the tooling effectively in our organization? But the other part is, is it actually making us faster? Is it helping us deliver better products? Is it helping us deliver faster? And this is where I think the DORA metrics really play a core part. And I think for me, when we talk about developer productivity, it does go back to the fundamentals. So, is our deployment frequency increasing as a result of introducing this tooling? Is the lead time decreasing as a result of introducing them? And similarly, if we are using this coding assistant, does it mean that we're getting more issues into production? And lastly, how long does it take us to restore from these issues? Is it harder to debug because now all of the code is written by AI instead of a human, and we don't understand it, right? So these are the metrics that, together with the usage of the coding assistant, can help us get a better picture of how we're doing. And this is just an example of a dashboard that can track all of this in a single place. So next, let's talk about how AI is changing the way that we observe. So at Datadog, we have built many features that are based on machine learning and LLM, and I guess probably many of you would have been asked to include AI in some way, shape, or form in your applications. Maybe can I get a quick show of hands? Who's being told, can you add AI in some ways? Okay, right. So all of us are being asked to do this. And the thing is, when we're adding non-determinism, when we're adding complexity in our tool, we're now basically getting applications that can decide their own execution flow. In some cases, you might have agents that can decide how to query a database. And just think of the type of impact that that can have on your platform. So 2 user requests are not necessarily going to behave in the same way. They're not necessarily going to have the same impact on your platform. Maybe some of them are going to take many more CPU cycles than others. The second part is hallucination. Previously, without AI, we can simply test our applications and know that it's doing well, it's performing well, and we can improve over time. Now, with hallucinations, there is an additional component that not only can mess up the execution flow, but actually can cause some real business issues behind the scene. Let's say if an AI suggests that we can give a contract for free or something like this. Third part is cost. Now picture this. You've got 2 requests from the same users with exactly the same prompt. But somehow the underlying data has changed, or the underlying prompt has changed, and as a result, you now have a request that is twice the size. So those 2 requests, now one of them costs you double. So being able to track that is really important in a world where you're embedding AI into your applications. And the last one is security. So we all know that with security, we have now a new attack vector when it comes to AI, which comes in the form of prompt injection. So how do we address these issues? For the complexity, main thing that we can do is making sure that we have got end-to-end correlation. So if you have observability within your agent and within your AI applications, and you can see how it correlates to the rest of the platform, you're then able to determine For example, if there is a CPU spike, is it due to some prompt that change, or is it due to some users that are misusing our tooling? When it comes to hallucinations, we want to be able to continuously evaluate these prompts and the responses from LLMs and use that as a feedback loop back into our development. So in situations where, generally with software you will deploy, you will look at the metrics, okay, and you can improve in some ways. With LLMs, you do the same, but you do it on a data quality side. And you need to be able to evaluate that continuously. Then there is the cost. Maybe you are in an organization where you're trying to centralize access to an LLM, and let's say you're a platform team, and you want to be able to attribute cost to each of the teams, so you know which applications is spending the most. Or maybe you want to know that who are the users that are spending the most on our platform, who are using this tooling the most. And this is where you want to be able to get metrics at a token level and attribute them to individual teams or also to specific users. And lastly, on security, you want to make sure that you have some monitoring and guardrails in terms of how the tools are called behind the scenes, if you have any prompt injection attempt, and so on. And if you have all of this, then this is what it could look like. If you see at the top, so this is a single user request. At the top, you will have the duration, the estimated cost for a specific request, which LLMs are used, and things like the execution flow inside of it. And now let's get to the last part, which is how AI is changing the way that we troubleshoot. So we've spoken about complexity, and we mentioned that complexity is only increasing, and with AI, that complexity is increasing even more. So picture that you now have more applications than ever before, you have new protocols. How do you go and troubleshoot issues? Of course, AI can help us with this, but for me, there is more than that. So what if we could use AI to interact with the observability data, but can AI do the whole thing? Obviously not, but we'll get to that in a second. So let's say that here's a small example of how I can use Cloud Code to interact with the observability data and look for errors in the logs, and eventually open a Jira ticket for one of the issues that the LLM has used. But this is just to show you that you can use LLMs for the coding part, but you can also use them for the troubleshooting part. And this is helpful when you have so many applications and different ways of interacting with them. So yeah, it's just a small example. Maybe I'll skip this. And yeah, so let me get to the next part. So when you can get AI to interact with that data and do this part for you, you're probably wondering, okay, well, what if we could take it further and actually get AI to investigate the issue? This is exactly what some of the engineers at Datadog have come up with. So they thought, well, what if we could run 10, 15 different hypotheses in parallel, check on the metrics, and then figure out which of these hypotheses is correct and where potentially is the root cause of an issue. And what if I could interact with the investigation to find out where the issue happened? But of course, like the previous part, I think the fundamentals are still crucial. Because you can have AI tooling that does this, but what if the person that reads the AI tooling is not trained properly? What if they don't understand the underlying languages or frameworks that are being used? So it's really important that we have got the right people with the right training. It is important that we have the right processes. When there is an issue, do we have runbooks and playbooks? Are we able to figure out, I think to the previous speaker point, are we working as a team to resolve an issue? And lastly, do we have the right technology that helps us debug and troubleshoot and get to the bottom of those issues? So really, for me, the fundamentals are more important than ever. So just to conclude, I think we've all seen how AI is changing the way that we work, and in specific, in this presentation, we've seen how it changes the way that we build, observe, and troubleshoot. The fundamentals are still important, so your DevOps practices, testing, security, all of these are going to continue to be key, and you should invest the right amount of time on them. And lastly, the tooling will improve, will adapt to this new world, and we should be here to adapt together with it. And that's it from me. So I'd just like to say thank you very much for listening to me in English this morning. And if any of these parts were interesting to you, myself and a few colleagues will be in the expo hall. We'll be happy to talk to you. Yeah.